Jochen did this talk about everything everywhere all at once, where he's making vector tiles that bring all the data into your browser where you can then view them. I'm using a similar backend to what Jochen does. I'm also using a Postgres database with OSM to PGSQL and then loading all the data into the database. But with this approach that I'm presenting here, it is basically, it's the user who has to make a query, which is then sent to the database, and then the database figures something out and sends the results back. So it's the same data, you have access to all the data, but you need to basically formulate a query. Let me start with a little bit of history about OpenStreetMap databases. So we have the standard editing API that you all know that is used by the editors to download some data and let you edit it and upload again. Initially, this API had some filtering functions. So you could say, give me all objects that have these tags. I think that has been discontinued for a long time. In 2007, we had something called Zappy, and 2011 something called JZappy came out that was intended to replace that or improve that filtering function. So you could formulate some more complicated queries about that would allow you to ask for larger areas with things filtered by certain tags. And in 2011, Roland started the Overpass API. There will be a talk about Overpass just after this. Initially, the Overpass API query form looked like this. There was basically a form where you could enter a query if you knew how to word the query. And then people would ask on the forum, how can I extract POIs for a region? And then they would get answers like this. Oh, well, you do this, then you can find out, then you put this query into the form, and then you copy this and then paste this, and then maybe you get a result, which obviously wasn't great. It was difficult to use, difficult to learn for people. And then something really great happened. Martin, who isn't here at this conference right now, came out with the Overpass Turbo website in 2013. And Overpass Turbo is a website that lets you just put an Overpass query right here and then hit run, and then the Overpass query is executed by the standard Overpass server in the background, and then you see all the results on the map. This was really great, and from then on, when people had funny questions on the forum, the response would just be, well, this is the Overpass query, but you can also just click here to run it, and then they would be sent to Overpass, where the query would immediately execute. Great thing, but I was unhappy because I'm a Postgres guy, and I like SQL. I like writing cool PostGIS queries. And often I would think when people were asking these questions, hey, you could solve this so easily with Postgres if you only had the data. Just take the file, the Germany file or the Europe file, load it in the database, and then you can run this easy query. Problem being, obviously, nobody just had a PostGIS database with OSM at hand. Well, not everyone. Many might not even be running Linux, so it might be more difficult to install all the things. And nobody was stupid enough to just run a PostGIS database where everyone can just make up queries over the internet. And then I thought, well, why not do that? And I did something called Postpass, which is basically a wordplay on Roland's Overpass. It's basically doing something similar, but with a PostGIS backend. The way this is built is really, on the server side, it's really just a small wrapper that takes queries via HTTP and then executes them on Postgres or PostGIS. The source code is on GitHub, and I'm currently running, because I'm also running GeoFabric, so I have access to lots of servers, and I'm running this on GeoFabric servers right now. But it doesn't have to be. I could envisage PostGIS or the OSMF or anyone maybe at some point taking this over if it establishes itself well. Otherwise, I'm happy to continue running it for a while. It goes like this. This is an example where you just run a curl command. You have to enter this URL, and then you send a Postgres query like this. Select something, tags name, geometry from a certain table where these tags are set, and the geometry is in this bounding box. And then what you get back is a GeoJSON feature collection that you can then process. Now, some people in the audience might see this and might say, wait a minute, what's he doing there? Obviously, if you let everyone execute Postgres commands on your database, they could do stuff like drop table so-and-so or something, right? So there are some safety measures against someone just dropping a table or writing into it. I'm just using a read-only Postgres account. So the wrapper connects to Postgres with a read-only account, so just no writing is possible. You can still create problems by doing silly queries that take a lot of computing time or return a huge lot of data, like select asterisk from everything. Now, what Postpass does is, at first it runs an explain command, basically takes the query that you sends that to the database and asks the database, how expensive will this be if I run it? And the database says, well, this is going to be really expensive, or this is going to be quick. And then depending on what the response of the database is, there are different queues for slow, medium, and fast queries. And faster queues have more workers. So if you send a query to Postpass where the database says, oh, I can process this real quick, then you get one of the many quick workers. And if the database says, oh my God, this is going to take an hour, then you get one of the slow workers. And maybe there are only two slow workers. So if many other people have queries that take an hour, then you have to wait. But on the whole, it seems to work rather well. I have prepared a couple of examples for you where I have put Overpass queries on the left and an equivalent Postpass query on the right. So in Overpass, this would be a query that gives you nodes tagged as fast food in this in this bounding box. And in Postpass, it will look like this. It's similar and similar execution time, so it works about the same. This is the same query. Well, the previous query was just for nodes, and this query is now for nodes, ways, and relations in Overpass. Or here I have a helper table called Postpass point polygon that contains all the points and polygons. So this does about the same as well. The database schema behind that is more or less standard OSM to PG-SQL now with the flexible backends. There's no such thing as a standard thing anymore, but we have basic tables for point, lines, and polygons. So all the stuff from OpenStreetMap gets processed and gets put into these tables. The columns are an OSM type, an OSM ID, and then one column for the tags and one column for the geometry in EPSG 4326, so latitude and longitude. The tags column is a JSON, not an HSTOR column. So it can hold all the tags. I don't need like one amenity column, one cuisine column, one tourism column, and so on. I can just have one tags column that has all of them. And I have a couple of views for convenience that combine these tables. So there's a Postpass point line view that combines the point and line tables and so on. And sometimes you want to make queries against several of these. And I also have the so-called middle tables that store the relationships between ways and relations, or between nodes and ways. I'll not talk about them much more in this talk, just one other slide. There are some details about the data schema on this GitHub page. Some more examples. Some more complicated examples. Here is asking Overpass for a relation in this area with ref equals 3 and root equals tram, so that's tram line number 3 in Karlsruhe. Equivalent Postpass query on the right. Takes about the same time on both, so you can translate that rather easily. Here's a query that is looking for nodes and ways that have an address street tag but not an address postcode tag. In Postpass, you would say tags question mark address street and not tags question mark address postcode and geometry. So that works the same. Here's a query that takes 300 seconds on Postpass and only 300 milliseconds on Overpass. If you ask without a bounding box, if you say, hey, worldwide, give me all things that have this ref, and if you formulate the query like this, it'll be super slow on Postpass. That's due to how the index on the tags column works. that's a GIN index on a JSON-B column, and if you query like this, the index cannot be used. However, if you write your query like this, it's just a slight difference. It's the containment operator for JSON storage, then it can use the index and then it works super fast. That's one thing that many of you who have worked with Postgres or PostGIS in the past, you will know that indexes are important. Admin boundaries named Dundee. Let's skip this. One important thing, Postpass is geometry based. It sucks at problems like find all ways that have this tag and that are in a relation with that tag, or find nodes or tags that are nodes or ways that are untagged. If you want to do stuff like that, you can do that with the middle tables, but you're better off using Overpass, because Overpass uses the basic OSM data, stores the basic OSM data and the relationship between these objects, whereas Postpass stores geometries, right? So anything with geometries works well in Postpass. Now, my talk is called Overpass Turbo goes PostGIS, so I'm going to show you how Overpass Turbo integration works. Overpass Turbo always had a data source selector. It was rarely used by anyone. It converts Overpass data to GeoJSON, which is not needed here because we already get GeoJSON. So only minimal changes were required to support Postpass, and it's been live since March 2025, thanks to Martin Reifer, who runs Overpass Turbo. So here's an example for an Overpass Turbo question where you ask for fast food in a certain area, and I can show this on the thing. On the browser. So here, let me just increase the font size a bit. Okay, so I can just put the query in here. I have to put this data thing up here, and then I can just run this, and it's like it works with Overpass as well. You can then see your results here. You can click on them and see all the tags and so on. Right, how do I go back? Yeah. Right, next example. You can do queries that do not have geometries easily in Postpass. You just have to add some information to tell it that the query that you're asking does not return a geometry. So, for example, this query counts how many of certain amenities do I have in the current area. If you run this in Overpass, it will in Overpass Turbo, it will automatically notice that there are no response. The response does not contain geometry, and give you a count like this. So in the area that I have selected, there's the most frequent amenity is bench, followed by bicycle parking. Right, another example. I can sum up highway lengths by type, right? Similar thing, run this thing, gives you a JSON array as a result, saying, okay, you have so and so many meters of residential roads and so on in the current bounding box, obviously. Now here's something super complicated that I will not have enough time to go into, but what it does is it takes all the railway stations and looks at how many, it sums up the capacity of all bicycle parking in the vicinity of that railway station. So I had prepared some details about this, but I'm just going to run it for you now. So it actually returns, it's a query that returns a geometry, it returns a point for every railway station, and it returns a value called cap equals 223. So that's basically the sum of all capacities of all bicycle parkings within a certain distance of that station. So these are things that you can easily do with Postgres. I'm going to skip over the details about the explanation. There's another thing where you can basically say, hey, find land use areas that overlap each other in an area. And if I run this, it's going to take a slight bit longer. if you experiment with this, you will find out that every now and again you make a stupid mistake in a query and it will take ages, and then you just cancel it. It's no worries. But this has now not only found things in OSM, but has also computed the intersection. So what is returned here is not the geometry of the original OSM object, but the intersection of something. And I can click on this and it says, okay, there's 2 land use areas here that overlap in this area. One is grass, one is residential, or in this smaller area here. Let's look at this. It's also grass and residential, right? So you can use these things. You can come up with interesting queries for QA purposes. Somewhere on the Fediverse, Amanda recently accepted the challenge where someone said, hey, are there any towns in England without a Wetherspoons pub? And if you want, you can look at the details. It's on Amanda's Mastodon thing. She's come up with a 70-line query that tries to answer this query as a Postgres query. Right. Overpass Turbo is not the only service that can use Postpass. You can also use that in Ultra, which is an Overpass-like thing with vector tiles. There's also an explain endpoint that allows you. This is something that you cannot do from within Overpass Turbo. It's just on the command line, but it allows you to send a query and basically ask Postgres or ask Postpass, hey, how expensive is this query going to be if I run it? And you get a response that says, okay, this is going to be in the quick queue, and this is some details that Postgres gives you about how it thinks that the query should be executed. You can actually paste these things into a number of websites that explain the results to you and tell you what all this means. To close this, there's a small feature comparison. Requests with a bounding box can be done in Overpass and in Postpass, and they're often about the same. I found them to be slightly faster in Postpass frequently. Requests without a bounding box, if you say, hey, worldwide, give me everything that has these tags, you must use the containment operator in Postpass, otherwise it will take like hours. Working with raw OSM data, like I want these nodes or I want to know which nodes are in ways, this is difficult with Postpass and better with Overpass. Doing aggregations, like count the number of things in this area and then combine them according to certain criteria, is not as easy in Overpass as it is in Postpass, at least for me. And the same goes for geometry operations. If you want to say, hey, give me the intersection between all things that have this with intersections with things that have this other tag, that's quite easy to do in Postpass, I find. Final slide. Thank you. Patches are welcome. If you play with this and if you find any cool examples that you find should be added to the documentation, or if you find bugs, or if you do know anything about Go and you can improve my code, because this was the first program in Go that I wrote. I just thought, well, I should get started with this. Yeah, I'm super happy for any contributions and for people to try it out and play with it. The whole mission of this thing is to make people play with SQL or with OSM data in PostGIS more and give you ideas of, hey, I could easily, someone on the internet has claimed that this is the case. Let me run a query that tries to find out whether it's true or not. Thank you very much. Do we have any questions? Paul.
To anyone who knows me, it should be no surprise that I find this very interesting, having been involved with JX API and the PT snapshot stuff and similar things at the time. Is there some, rather than Postgres and PostGIS questions, which approximately no one, including me, will understand, more user-facing one is, does this work with the Overpass Turbo wizard, where you can do A equals B and so on?
No, it does not. That would require some more changes to Overpass Turbo, where basically what you would have to say is you would have to tell the wizard, hey, I would like to send this query to Postpass, so please try and generate a SQL thing. If anyone wants to have a go at this, I'm sure Martin would be responsive to that. So yeah, it doesn't do that at the moment.
Thank you. A really interesting presentation. I have two small questions. One of them is, does the explain score take into account the size of the bounding box? Like, if it's like if you're, I mean,
yes, yes, it does. When you formulate your queries on the Overpass Turbo website, then you just put these in braces bbox, and it will put in the bounding box automatically. If you do something on the command line with curl, you have to put in the bounding box yourself in numbers. I had that on my examples, and it will then the query optimizer will look at this query as a whole and make an estimation of how expensive this is going to be. If you, for example, if you were to select a very large bounding box that was like almost as big as the planet, then the query optimizer might run the query in a totally different way than it would otherwise do it. It would maybe say, you know, I'm not using the geometry index for this query because the bounding box covers half the planet anyway.
Does it refuse it then? Because you mentioned this query that took 300 seconds.
Yeah, it won't refuse that. It will process it. It is, however, possible that something on the line between the Postpass server and your browser will at some point say, wait a minute, this TCP connection has been open for 60 seconds, 60 minutes, and I'm just going to close it now. But there's no timeout in the system.
I have another small question. So when you try to generate overpass queries with like ChatGPT or any other large language model, it struggles with that. Is it better for generating PostGIS queries? Because I imagine it is, but have you like tried that?
I don't know. I'm not that much of an AI guy myself, but there's if you go to the GitHub page, someone has actually contributed a section to the README that says this is how you have to talk to AI to get the proper SQL statements back. So there are some examples there of how you have to formulate your prompt to get what you want.
TBD if it's better.
Yeah.
But, okay, thank you.
Did you make any tries to also add support for PG routing?
No, with PG routing. With PG routing, it would be much easier to run queries that take very long, and I don't know how well that would work with this explain approach. It could be tried out because this whole thing really relies on explain giving you a halfway decent response about how expensive this is going to be to run. And I fear that if I were to install a PG routing backend, I might not be able to get good enough explain results to find out whether this query needs to be put on the slow on the slow queue. Yeah. It's technically possible, though. I mean, if you install the software yourself, you could easily just try it out and install the backend and have a look.
A quick question about relations. You mentioned, I think I understood that you consider relations as lines or polygons, but is there a way to query completely arbitrary relation that involves points, lines, and other relations even in your system?
This is one of the things where I said Overpass will be better at doing that. The OSM to PG SQL will generate geometries for all the relations depending on what it is, either a linear relation or a polygon relation. And it will also store the raw relation in what we call the middle table. You can look at the data schema on the GitHub page. It says how this table is set up. And that will contain an entry for every relation, and it will also contain an array of members and an array of tags, or maybe a hash of tags. I think it's a JSON column of tags. So you could theoretically do queries like that, but they are a bit complicated to do because the object ID is stored in two columns. It's the type and the ID. So it's possible, but it's advanced SQL writing.
Have you looked at tweaking any of the Postgres query planner cost information or selectivity information?
Not at all. It's plain standard Postgres settings on Ubuntu 24.04, and I have not made any changes to them. I might, if you have some, if you have some selections, some suggestions. I'm happy to look at them.
So it's using just PostGIS. So if I had my own data, I could host this myself and join them up.
Yes, this is why I have split it up in two repositories. One is basically the Postpass software that you can run on top of any Postgres database that might not even have OSM data in it, but other data that might not, whatever. You can do anything. You can run it with anything. And then I have this Postpass ops repository where I have detailed how exactly am I running this thing with OSM data, but that's independent of how other people could run it. That having said that, Postpass is really only interesting if you want to sort of open this up to the public, because if you run your own database and you want to have like GeoJSON access to the data that you have in your database, then you're probably better off with some standard thing like the bbox server or GeoServer or map server or any of these that can do that out of the box. Okay, no more questions, and I can then hand over the mic to Roland, who's basically going to tell you something about Overpass, which is basically the competition. But I mean, it's more like this is the competition because he's been doing this for like, I don't know, well, long time.
It's concurrence, not competition. No, in fact, we are an open project and we need a little bit of resilience, and there are quite a lot of people who know how to write SQL. And so it's good if you could take advantage of your SQL knowledge. So I absolutely welcome this approach. It also means that for some edge cases where it would be a pain in the ass to implement it in Overpass, I could just send people to Postpass if it's halfway decent or completely decent in SQL soft.